This episode of Photonics Hot List is sponsored by Metallark Optics, where they take on what others won't. Challenge accepted.
Hi, I'm Justine Murphy, Senior Editor of Laser Focus World. Let's take a look at some of the amazing things happening in photonics. NASA-supported research led by a team at the University of Maryland is poised to advance our knowledge of what exists in our own solar system and what lies beyond, maybe even extraterrestrial life. The team has developed a miniaturized laser desorption mass spectrometry device that combines a solid-state UV laser source and custom ion transfer optics with an Orbitrap mass analyzer, which provides high-resolution data about a material's chemistry. This allows the researchers to identify compositions of materials, which could aid in detecting signs of life in outer space. Mass spectrometry, an analytical technique that measures the chemical composition of materials, has long been used for in-situ planetary exploration. This new device is capable of comprehensive analysis of trace organic compounds and inorganic materials on planetary surfaces. It's small, weighing just 8 kilograms. It touts relatively low power consumption and has been ruggedized, the researchers say, to maintain full functionality in the extreme environments in space. This makes the device highly capable of collecting substantial amounts of chemical information, which would make analysis and corroboration of the presence or absence of life more comprehensive. Using butterfly wings as inspiration, a team from the University of Michigan and the Defense Fabric Discovery Center at MIT's Lincoln Lab has engineered photonic fibers to make recycling easier and more efficient. Clothing and textiles can be difficult to sort for recycling, which too often pushes this class of potentially sustainable materials to the wayside. But rising material costs and the benefits of reusing fibers in new products are prompting an increased focus on recycling textiles. The new photonic fiber labels are woven into fabric, acting as invisible sorting labels, barcodes essentially. To create the fibers, materials that are otherwise transparent are organized into stacks of very thin layers or microscale patterns that refract and reflect light. In this so-called structural color approach, the fiber stems from a one-dimensional photonic crystal in which acrylic and polycarbonate materials are alternately layered. The researchers engineered the photonic fiber to respond in the near-infrared in high-throughput sorting equipment and provide definitive information about the fabric's composition through the encoded photonic information. This could make recycling more efficient and even help track sustainable material textiles throughout the manufacturing supply chain. We all know that when it comes to disease detection, the earlier the better. But tissue and cell abnormalities are often subtle in the early stages, so discovering them quickly is difficult. A team based in Germany aims to change that. Researchers from Helmholtz Munich, LMU Munich, and the Max Planck Institute of Biochemistry have created a spatialomics approach, specifically proteomics, the study of proteins expressed by a genome, cell, tissue, or organism, to better understand cellular organizations and interactions within specific tissues. Called DISCO-MS, the technique involves 3D imaging of solvent-cleared organs, essentially tissue clearing, to make a mouse body or human organs transparent and more accessible for imaging. The tissues of interest are then extracted with robotics technology and their proteome data analyzed using advanced mass spectrometry. This new approach allows complete molecular characterization of any desired tissue region to precisely identify sick cells early in a disease. And that's your Photonics Hot List. Be sure to like and share and subscribe to our YouTube channel for tons of cool content. Until next time.